Hello everyone, here's a demo to our deep learning project, classifying Lego bricks and deploying on SageMaker. The team consists of Sichuan, Alan, and myself. Image classification is an important technique in computer vision that has wide applications such as boosting productivity. We used a Kaggle dataset consisting of 16 different types of Lego bricks, each in 200 x 200 pixel RGB images. Next, let's dive right into our project architecture. We decided to use AWS because it has certain auto-scaling capabilities. We started with building a simple neural network and deployed on SageMaker as an endpoint. This endpoint allows data and model to speak to each other, which enables real-time online inferencing. Then we built an AWS Lambda to invoke on this endpoint. Right afterwards, we used a Amazon API gateway to create a REST API that can be used by a client application. In our case, we use the Locust to test the robustness of our production system. Next, my teammate will go into more detail on the deployment.
Now I'm going to introduce how we deployed and scaled our LEGO inference service. First, we uploaded our model file in S3 and then created this SageMaker notebook instance. Next, we edited the inference.py file based on our model and used this deploy Jupyter notebook for deployment. After the success indicator, we tested our model by passing this Lego brick image to the deployed model for inference. And as you can see, the response includes inference results. Then, if we navigate to the endpoint page, we can see there is a new endpoint shows up. Clicking the name of the endpoint, we can set the instance number and auto-scaling policy. In this project, we set the instance number to be 6 in order to handle lots of requests. Then we used Lambda function and API gateway to create the REST API. As you can see, this is the structure of our API. Then we launched a Cloud9 instance and used the load test tool Locust to test if our model can handle large traffic in a short time. So we can launch the Locust tool in this way. By the way, we have included all the materials that helped us to build this project, and also our project GitHub link in the description below. Check it out if you are interested. Next, Alan is going to introduce the load test result.
As Sito mentioned before, we verified the elastic scale-up performance of our model via a load test tool called Locust. You can see that we almost reached 700 requests per second, but there are still things that could potentially scale the model further. First, size of the SageMaker notebook that we're using. Second, number of instances running simultaneously. Third, the computing capacity of the Cloud9 environment that we're using as well as the CPU of our laptop. In summary, this is a video showing a pipeline of configuring a machine learning model on AWS SageMaker with auto scaling and load test with Locust. You can find all the work in our collaborative GitHub repository and references links in the descriptions. Thank you for your watching, and we're happy to hear any feedbacks.